Okay, today we're going to be covering one of the main three types of trigonometric substitution. First, you might be asking, why do we need trig for this? This is just a rational expression, is it not? And you'd be right, this is rational, but if we use what we've learned so far, like u sub, integration by parts, there's not going to be a compatible term. Like if you let u equal this, then this one's going to get in the way. So in this case, if we substitute tangent, we can actually reach some nice simplifications. Let's see how that works. Okay, so I'm going to begin by substituting x for 4 times tangent theta. And why 4? Because if we square this 4 here at the front, it's going to match the 16, which we can then factor. Okay, so squaring 4 tangent theta in the denominator, we're going to have 16 tangent squared of theta plus 16. Factoring the 16, we're going to have tangent squared theta plus 1. And if this looks familiar but you're not quite sure what it is, we can refer back to our Pythagorean identity, the base one. Okay, so sine squared theta plus cosine squared theta. So what we're going to do is divide all of these by cosine to make a tangent term. Okay, so this divided by cosine squared is going to be tangent squared theta. Cosine divided by cosine is just going to be 1. And 1 over cosine is going to be secant. And then we square it. Okay, so now we can substitute back into what we had here. Okay, so our denominator turns into 16 secant squared theta. Okay, great. So what does this mean for our integral? Okay, and this turns into 1 over 16 times 1 over secant squared, which is going to be cosine squared. Okay, but before we get to integrating, if you know how to do that from here, we have a little problem. And it's that we're integrating with respect to x, but we have a theta. Let's see how we can get rid of this. Go back to original substitution, which was that x is equal to 4 tangent theta. Differentiate the left and the right side, just like in u substitution. Dx is equal to 4 derivative tangent, remember that, secant squared theta. And with respect to theta. So really, we don't want this form. Because here, when we multiply by this, it's going to cancel. One over 16 secant squared theta times the new dx, which is this expression. 4 secant squared theta d theta. Okay, and now that we back substituted d theta, we don't have to integrate the previous expression, and we're going to see something nice happen here. Okay, obviously the secants are going to cancel, and 4 over 16 is just 1/4. Okay, so now we're left with 1/4 d theta. And just like in normal integration, if we had just 1/4 here with respect to x, it would be 1/4 x. Similarly, this is going to be 1/4 theta plus c. But are we done yet? The original problem had us differentiate with respect to x. So we have to get this theta back to x. Okay, so to do that, let's recall what we substituted initially. We had x is equal to 4 tangent theta. Okay, so then x to the 4 is equal to tangent theta. And finally, theta is equal to arctan of x divided by 4, which leads us to a final expression of 1/4 arctan, or inverse tan if you prefer that, x to the 4 plus c. And we are done.